508 meters tall and 101 floors from ground level, the building looks completely unique. Most skyscrapers has exterior walls that is either straight up and down or sloping in. But Taipei 101's unique shape sees most of its exterior surface sloping out, broken into sections resembling a stem of a bamboo. Thus, the shape of Taipei 101 is more complicated than regular tall buildings to work with, making it challenging to build. Taipei 101 is located in Taipei, which is the capital of Taiwan, located in East Asia. It is currently the 10th tallest building in the world and was the tallest from 2004 to 2010. The project consisted of a 5-storied retail mall and 101-storied office tower. If we see the site in plan, the yellow portion is for the office tower and blue for the retail mall. In order to get to know about Taipei 101 deeply, history should be handled. In 1997, the Taipei Financial Center Corporation, a team of several Taiwan banks and insurance companies, won the rights to list the site for 70 years and to develop a building. This was the start of the famous Taipei 101. In 1999, construction began. In March 2002, when the process was partially done, a major earthquake struck Taiwan, destroying a construction crane at the rooftop, which was at floor 47. However, an inspection showed no structural damage to the building, and the construction work was able to start within a week. Taipei's roof was completed 3 years later on July 2003. In 2009, Taipei Financial Center Corporation announced plans to make Taipei 101 the world's tallest green building by summer of 2011 as measured by LEED standards. 2 years later, in 2011, it became the world's tallest and highest used green building, as well as the world's largest green building. Every major skyscraper in the world is a trade-off between what will look good and what will stand out. Thus, every skyscraper project has a list of challenges, but for Taipei 101, that list is longer than size alone would imply. Starting with the foundation, we'll look through wind, height, and seismic issues that Taipei 101 faced at an early stage. Let's start with the first one, the problems related to the foundation. We all know that foundation is one of the most important factors to consider when a building is being raised. It is also true for skyscrapers like Taipei 101. Foundation in good conditions would be the ones that are solid enough to bear the heavy weight of the building and distribute the load to ground below. However, in Taipei, finding a solid ground is almost impossible since the changing sea levels turned the ground into silt and clay for over hundreds and thousands of years. The ground that was placed right below the top level was too soft and unstable for Taipei 101. This difficulty was solved by reaching all the way down to the bedrock and digging out all the watery earth. Is there any of you who have been to Taipei? If you have, you will definitely be aware of the scary wind. The wind itself is pretty strong on regular days and have impacts to skyscrapers. In general, force of the wind becomes very strong as it moves away from the surface. At the top of the skyscrapers, even vortice, which is a spiral phenomenon, appears. And the low pressure is created on the other side of the building, causing it to shake. If they weren't solved, Taipei 101 would be moving over 1 meters from the wind and causing motion sickness to people inside. What's worse is that many times typhoons pass right through Taipei, causing extreme risks. All these things were the potential and basic problems when designing Taipei 101. So the engineers struggled to design Taipei 101 to go beyond the wind standard of a typical building. As a solution, there are a few things that we should go over. First is the damper. The structural damping coming from the wind is complemented by a huge tuned mass damper, which we call it TMDs in short. To mention its working process briefly, the TMDs move in the opposite direction of the building's movement. Also, the shape of the corner of the building is used to eliminate hydrodynamic obstacles. If you close your eyes and picture Taipei 101 in your mind, it is more likely that the first thing you can think of is its height, not any other details. This is how much the height of Taipei 101 is representative and have impacts on people. However, raising a skyscraper was a daunting task and still is, compared to typical buildings that we can see around. It includes the financial parts. As the building goes higher, the need of elevator shaft, stairwell space, mechanical, electrical, plumbing, and fire protection risers also increases. More importantly, structural issues of how the floors will be piled up without falling apart was a challenge. Some structural methods were applied, making Taipei 101 still alive. Until now, we looked over some of the weaknesses regarding Taipei 101's design issues that they encountered when designing the world's tallest building at that time. Many of them were related to the environment of the site where the building was planned to be built. More to the weak foundation and the windy weather, Taipei is in the boundary where earthquakes strikes often and severely. This picture shows the epicenter of earthquakes occurred during 15 years. We can easily realize that Taipei is a vulnerable area. Even during the construction period of Taipei 101, earthquakes occurred several times even in small sizes. Earthquakes are not a daily basis event that we run into, but skyscrapers need to consider it, unless it would cause terrifying results when it happens. So the earthquake issue was needed to be handled structurally. A thing that bothered was the enough stiffness of the building to withstand the wind wasn't able to endure earthquakes, and the enough ductility of the building to withstand the earthquake wasn't strong enough to endure the winds. So the engineers came up with the idea of designing the building first mainly considering the stiffness and then testing earthquakes later on. Also, several systems were applied as a solution to the severe earthquakes, including tuned mass dampers. Applying dampers will reduce the movement of the building by a lot. We looked over some issues that Taipei 101 had during early stage. Based on what we've been through, we would study how they solve them from next week. After that, we are planning to focus on challenges for operation and maintaining the building. And for the last, we'll study the construction process based on the knowledge that we collected for weeks.